on the second equation, because it has too many decimals, it's not easy to manipulate equation like that. So we multiply 100 into the second equation, and then I rewrite the second equation into the 5x plus 6y plus 7z equal 142400. We multiply 100 into it. From the first equations, I can rewrite the first equation into the z is equal 23,000 minus x minus y. From the third equations, I can rewrite the y is equal 1200 plus x. So as here you can see, I try to rewrite the y and z into the x term so that we can narrow down from 3 unknown into 2 unknown, and then until we get a single unknown. So from here, I let the y equal 1200 equal x. I can substitute the y into the first equation term here. So let's do it. Z is equal 23,000 minus x minus y. Y has 1200 plus x. So from here, we can simplify from 2 unknown x and y into the single unknown x. So minus x minus 1200 minus x. So now we get a 21800 minus 2x. So this is a z. Z is equal to 21800 minus 2x. Now we can substitute the x, y, z into the second equation. But the difference is I rewrite the y into the x term. I also rewrite the z into the x term. So we only have the single variable x remaining on the second equation. Let me show you the work. We keep the 5x the same, so 5x remains 5x. 6y, so plus 6y, I'm going to rewrite the y into 1200 plus x. Plus 7z, I'm going to put down here, plus 7z. Now I'm going to substitute the z into this form. 21800 minus 2x. So this is x, this is a y, this is a z. Equal 142400. Now if you look at the entire equation here, we only have the single variable x. So we can solve for x from here. Now we have 5x plus 7200 plus 6x. Now move on to 7, multiply 21800, we get a 152600 minus 14x equal 142400. We combine like term. This 3x sum them together, we get a negative 3x. Bring all the number to the other side and subtract from 142400. You will get a negative 17400. Divide by negative 3 on the both sides. You'll solve for x equal 5800. So that means this is 5% of the investment amount. You solve the y, you solve the x. Now the x just simply to plug in back to here. Then you'll get a y is equal 7,000. So this is a 6% portion of the investment. You solve the x, plug in back to here. You will find the z portion. So the z has 10200. This is 7% of the investment. So you have to solving for this type of question, you need to be able to recognize the easier way to manipulate would be rewrite the other two variables into the same term of the variable. For example, I use the x here. So I rewrite a y into something x. I rewrite a z into something x. And then you narrow down from 3 unknown into the single unknown. Once you solve for the single unknown, you can plug in the number back to find the other two. And once we move on to 6.3, you can use a calculator to solve for this type of question. It will turn to super easy. Alright, so if at this moment you get confused, don't worry about it. Now we do the other two questions. The first question we have x plus y plus z equal 12. X plus z equals 7. And the 2x plus y plus 2z is 19. So the first step, I'm going to rewrite the z. Alright, from here, I'm going to rewrite the z into the 7 minus x. I rewrite the y and z term into the x term. Now I'm going to substitute the z, okay, because I have the two other equations, they have the same pattern, so it doesn't really matter. I substitute the z into here, and I also can substitute the z into here. So let's rewrite x plus y plus 7 minus x equal 12. So now the first equation, it turns to the x, because this, alright, let me remove the parenthesis here, minus x equal 12. Now x cancel out, so you have the y is equal 5. Nice, we get a single value of y. Alright, now we substitute y into here, and then substitute the z into here. So on your third equation, I have 2x plus 5, because y is 5. Right, we substitute into here. Plus 2z, I'm going to rewrite a z with 7 minus x is equal 19. So you have 2x plus 5 plus 14 minus 2x equal 19. Now 2x cross out. 19 equal 19. This information tell me these three equations, no, I should say your x and z, they are rely on each other. So it doesn't matter whatever number you plug in into the x term here or z term here. As long as you keep the y is 5. Now we solve for 19 equal 19. That means you will have two the solution. We have 19 equal 19. That means this is a true statement, right? So we have the consistent equation. Consistent. That means your y, your z, and x, they are dependent equations. When we provide the solution, we only keep the single variable x. So your x, always write down the x term, never change. Now the y, you already solve for y is 5. Z, we don't put down the z because your z is rely on your x. So the z is equal 7 minus x, and that is the solution set you provide to the question. From your solution, you only have the single variable x. If the y, right, we are lucky we get a y equal 5. If you don't have the single number 5, you have the y equal something. Then you need to get the variable x. In other words, you have to rewrite a y equal, for example, 12 minus x. And then you provide this solution into it. But this is not a case because we solve for the y equal 5. And your z term, you rewrite into the x term. And that will be the solution. We do one more. This example, we have 5x minus y equal 12. And on the second equation, it gives us y is 5x minus 12. So we can use the substitution to plug in back to the first equation. So you have 5x minus 12 equal 12. This is y, right, from the second equation. Now we solve it. 5x minus 5x plus 12 equal 12. 5x cross out, you get a 12 equal 12. This is true. So that means you have consistent equation. That means these two variables, they are dependent to each other. Now, how do you write down the solution? You keep the x by itself. Your y is 5x minus 12. And that's it. That's a solution set of this question. And these two equations, they are consistent equations. So this is section 6.1. I know it's a little bit confused, especially when you have 3 unknown variables, but we do this section 6.1 by hand. So you need to combine substitution, elimination, or sometimes you have to do both in order to solve for your XYZ. Once we move on to 6.3, you will know how to use the calculator.